Let us learn another problem from current electricity. Three identical lamps, each having a resistance R, are connected to the battery of EMF epsilon as shown in the figure. Suddenly, the switch S is closed. Look at the diagram. A. Calculate the current in the circuit when S is open and when S is closed. Solution. Current we find when the switch is open. When the switch is open, the current flows through three bulbs. So the total resistance of the bulb Rs equals R1 plus R2 plus R3. All these bulbs are having same resistance. So we write Rs equals R plus R equals 3R. Therefore, the current is given by the formula I open equals epsilon by the effective resistance Rs, which is equal to 3 times R. So I naught equals I open equals epsilon by 3R. Let's write this answer close to the question. Now, let us go for when the switch is closed. Look at the diagram. The S is closed. The bulb Z does not glow because there is no current flowing through it. Now there are only two bulbs with resistance R each. So the total resistance Rs now equals R1 plus R2. So each equals capital R. So Rs equals 2 times R. Therefore, the current now in this switch S closed condition is I closed equals epsilon by the effective resistance. So IC equals epsilon by 2R. IC equal to epsilon by 2R. So as the resistance decreases, the current will increase in the circuit when S is closed. Let us go for the second question. What happens to the intensities of the bulbs A, B, and C? Brightness of the three bulbs in series is given by a formula P1 prime equals P2 prime equals P3 prime equals I naught square R. The current in this circuit is same for three bulbs, so I naught is same, but the resistance of each bulb will be different. But in this particular problem, all the bulbs are having same resistance, so I naught square R is the brightness of each bulb. For detailed explanation, I have given a detailed video on this particular topic that is given in the description box. Please, okay, go and check that out. So P1 prime equals P2 prime equals P3 prime will be equal to the I naught that we have already found that is equal to epsilon a square. Yeah, I naught square will be equal to epsilon naught square divided by 9R square into R. So R and R square on R cancel. So the answer will be epsilon naught square 9 by R. So all the bulbs glow with equal brightness is the answer. Brightness of the two bulbs in series because S is closed. So P1 prime will be equal to P2 prime, that will be equal to IC square R. IC, the current in closed circuit will be right epsilon by 2R. IC square will be equal to epsilon square by 4R square into R. 1R cancel. So epsilon square by 4R is the brightness of each bulb P1 and P2. So the third bulb where there is no current, there is no glow. So P3 will be equal to 0. The brightness of the bulbs A and B are equally increases. Bulb C will not glow as no current pass through it. Right? Very good. Calculate the voltage across the three bulbs when S is open and closed. Voltage across three bulbs when switch is open. VAO equals IOR. VA open equals IO is given epsilon by 3R into R. So RR cancel. So VAO will be equals epsilon by 3. So similarly, right? The voltage across B, the voltage across C will be having the same value because current is same, resistance is same. So the voltage across each bulb also same. So VBO equals epsilon by 3, VCO equals epsilon by 3. So VAO equals VBO equals VCO equals epsilon by 3. Now let us look at when the switch is closed. VAC equals ICR. IC is given already. We found that. So that is equal to epsilon by 2R times R. So VAC equals epsilon by 2. Similarly, VBC equals epsilon by 2. But the voltage across C will be equals 0 because there is no current flowing through it. VAC equals VBC equals epsilon by 2, whereas VCO equals 0. Calculate the power delivered to the circuit when AC is open and closed. The power delivered to the circuit when switch is opened. PAO equals VAO IO. So VAO we have found that is equal to epsilon by 3. IO we have found that is 3 by epsilon by 3R. So we are using that here. VAO equals epsilon by 3. IO just take out from the answer epsilon by 3R. So the answer will be PAO equals epsilon by 9R. Right? This is where we used to find the brightness of the bulb. Remember that. So similarly, power delivered by the bulb B when the switch is open equals the same value epsilon square by 9R. For the bulb C, PCO equals epsilon square by 9R. PAO equals PBO equals PCO equals epsilon square by 9R. When the switch is closed, PAC equal to VAC into IC. VAC we have already found that when the switch is closed, that is epsilon by 2, and IC we have found earlier, that is epsilon by 2R. So the power across A when switch is closed equals epsilon square by 4R. Similarly, PBC equals epsilon square by 4R, whereas there is no power used by bulb C, so PCC equals 0. PAC equals PBC equals epsilon square by 4R. PCC equals 0. Thus, the power delivered to the circuit decreases, increases, or remains same. When three bulbs in series, the effective value of the power given by the formula 1 by P equals 1 by P1 plus 1 by P2 plus 1 by P3. So we have found this value earlier. Let us substitute all these value over here. 1 by P equals 1 by P1 becomes 9 R by epsilon square plus 9 R by epsilon square plus 9 R by epsilon square. So it's equal to 27 R by epsilon square. So P equals epsilon square by 27 R. Let us go for when two bulbs in series, that is the switch is closed. 1 by P prime equals 1 by P1 plus 1 by P2. So now the power when switch is closed is given earlier, which is equal to epsilon square by 4R. Right? Okay, we are using it here. It's not 9R, it is 4R. Correct? When closed. There is an error over here. Let us check out this. Right here, it wouldn't be 9, it would be 4, right? 4. Here too, it is 4. So this will be now 4 plus 4, it will be 8. 8R. Okay, good. So P prime will be equal to epsilon naught square by, it's not 18, it is 4 plus 4, it is 8 R. Okay, good. So look at P and P prime, right? P prime is greater than P. So we give a conclusion P prime is greater than P. So the total power delivered to the circuit increases. Thank you, children.